Hi, my name is Ryan Regan and this is the journey of Whac-A-Mole Mathematics VR. Before starting this project, I conducted a literature review around gamification and educational content for virtual reality applications. The goal was to find out if making an educational experience for a VR platform could be successful. The measurement of success would rely on whether an educational experience could be delivered in a game setting, but also provide a more engaging and fun experience overall. In short, the goal was to make learning fun. Another key component to the literature review was understanding motivation within arcade and VR games. One of the findings mentioned was that of extrinsic rewards for players. Something I would like to later implement within my game would be a high score table where players are able to enter their name and save it to compete not only with themselves but also local users too. The majority of this project runs alongside the gamification research discovered during my literature review. Whilst conducting my research, I learned that there have already been proven instances where gamifying learning wielded positive results. The inspiration for this project came from my daughter whilst observing her doing homework. The task was to circle odd and even numbers throughout an A4 piece of paper. She looked very bored and unmotivated, which sparked my idea for the project. The question was, how do I make this maths homework fun and engaging so that bribery was unnecessary and she and others could learn this mathematical content with a smile and be happy to keep engaging with the experience? This is when the concept of merging Whac-A-Mole and mathematics came to be, which leads me onto the design and build process. One of the things I had to be mindful of was the fact of this game being virtual reality and the possible challenges that could bring for the users. As mentioned previously in my literature review, motion sickness can be a pitfall for VR players. This was due to the conflict of sensory signals combined with the vestibular system. For example, in real life, if you were to trip over whilst walking, your body would feel all the predetermined physical feelings such as air rushing past, stomach churning sensations, and then ultimately the physical ground that they land on. In VR, although the user would see the visual side, their body would not get the expected physical input from the environment, thus leaving the player in a state of physiological confusion. Another example would be that when you are looking around an area in real life, your vision speed matches the speed of your head turning. Whereas in VR, this does not always marry up, as the head tracking can be set at a speed that would not match the user's stereotypical natural movement. Therefore, to mitigate this, I chose to build the entire game in a small play space environment as opposed to open world, meaning that the user would not need to traverse over distance, which can cause the feeling of nausea. I feel like this was done successfully, as one of the questions on the feedback forms was specifically about motion sickness during the gameplay, and the results were as follows. 11 participants stated that they were able to play the game numerous times without experiencing any motion sickness, and one participant who had never used a VR device before played the game once and did experience slight motion sickness when looking around the environment. To combat this, I would look at fading the edges of the screen using a vignette effect, as this would allow for the player to have primary visual focus on the object in front of them, whereas the peripheral areas would blur slightly to give the impression of actual 3D viewing. Since completing my literature review, I have found information regarding these sorts of issues for VR players. There are now several devices such as the HTC Vive Pro Eye that have built-in eye tracking, which is designed to help the user have a more natural view on VR play space by getting the visuals to act as they would in real world by keeping the main objects of view in focus, whereas the outer objects are not as crisp and defined. Next was the actual design element of the game itself. At home, I have a whiteboard I use for my designs. I drew my mole design along with jotting down some of the behaviours I wanted. I also used this to help pseudocode the code structure to figure out how the different elements communicated with each other. It was also handy for documenting bugs and quickly working through them. My next goal was getting the mole hit animations working and testing this behaviour before moving on to the spawning. Now, I noticed the moles would spawn together, which wasn't my desired outcome. I quickly fixed this and moved on to the next round of testing. This was my first mole spawn script. After testing this behaviour, I knew it wasn't quite the desired behaviour I wanted, so I made a new spawn behaviour that more closely worked as I intended it to. Now the moles were spawning closer to how I originally envisioned. It was time to set up a particle effect for the mole being hit, then adding sounds, using my own voice in the Audacity software, then implementing some of the UI. This is what that looked like once these steps were complete. You may notice that the score wasn't working quite as intended, but that was a simple code error that I overlooked, but promptly fixed. Arcade-style games have a stereotypical look, where being the player walks up to the machine and presses buttons or levers to access the desired game mode. As you can see, there were several prototype builds for Whack-A-Mole machine itself. I chose to use ProBuilder, which is a tool integrated with the Unity engine, as I have some experience with 3D modelling. I could build a more realistic example of a machine, but also create the hammers that the user wields. This was to generate a more aesthetically pleasing design that the user could engage with. When I settled on the final design of the machine, I chose to implement selection buttons as they stayed within the original arcade machine structure and allowed players to begin the game without directed instructions on the screen, which meant that the user interface was diegetic as opposed to overloading the user with UI overlays. Unfortunately, due to the configurable joint limitations, there are some mechanical issues with the buttons, where being if the player interacts with the buttons when using the hammers, it can cause undesirable outcomes, such as the button moving past its limited threshold. Additionally, the player collider also being able to activate the button, which I could fix with the physics layers. But I also received some feedback from the questionnaires relating to the button usage. One participant felt the buttons were situated too close to the start game button, and sometimes the button themselves did not work as desired. Another challenge I encountered once having built the machine was the inability to change the player's height setting for each individual game. To combat this, I implemented a platform which the player had the ability to control, meaning they were able to adapt their height to suit their individual requirements and preferred playing stance. This also had a trigger box to detect whether the player is on or off the platform. This meant that the platform would not function without the player's presence. When the player moves from the platform, it automatically reset its position to the floor. I implemented this by adding a script to the buttons that will increase or decrease the platform's height by a specific amount, but also a clamp that restricts its movement between a minimum and maximum range. This is to stop undesirable gameplay bugs. Additionally, I also made the buttons function on release rather than pressed. This produced a more realistic interaction whilst containing the ability to button mash, which would certainly produce more undesirable outcomes. However, for future iterations, I am leaning more towards the machine itself being the component that is movable as opposed to the platform. I just feel that although the platform movement is effective, it feels like an unnecessary step, as when the player moves off the platform itself, it resets it to its original height, whereas the machine would stay at the desired level all the time. Now, let's look at a key component of the game, the hammers. At the very start of the process, I was unsure as whether I would be using a hammer, an axe, or both. After a bit of deliberation, I decided that the hammer would be traditional in the sense of it is what you would find on a whack-a-mole arcade machine. Also, the axe would chop the moles in half, thus leaving a gooey mess. In this instance, there was only one variation made, as they looked and worked as they should. They are connected automatically to the player's hands upon the start of the game. One participant gave some verbal feedback in relation to the hammers, stating that it could be beneficial to increase the length of the hammers to allow for a full reach of the moles without having to lean. This is something that I would be looking at implementing at a later date due to the time constraints of this specific project. At the start of the process in relation to the hammer build and design, I put together a prototype to test out the tracking modes with the XR Origin. This was to test the movement and functionality of the hammers to assess their behaviour when interacting with other objects, and to which type of tracking would best suit the purposes of this project. There are 3 types. There's velocity tracking, instantaneous tracking, and kinematic tracking. After I played around with the different options, I decided to run with the velocity tracking. It provided the most realistic physics collisions, whereas the instantaneous and kinematic tracked objects would pass through other objects. Seeing as the player would be operating in a small space, I wanted the interactions to be realistic and interact as expected. However, I later realised that although velocity tracking provided the most realistic interactions when moving around and swinging the hammers, it caused a lag or jittery movement, which broke the immersion. I decided to change the tracking mode to instantaneous to negate this occurrence, which also meant that the hammers could now travel through other objects, which was not the desired outcome but was a necessary alteration. Moving forward, there were issues that delayed the project's progression. This was due to being unable to create new game builds for testing. I tried to go back to a previous copy of the project, but the errors persisted. I had no choice but to create the project again from scratch, bar the research and development, to figure out what went wrong. This was where I found the issue, which was due to using Unity's and Oculus's recommended optimization settings for Android platform builds. I went back to the original project and altered these settings back to their default values, which resulted in the project being back in full swing. The time taken from this resulted in the progression window for the project being limited due to the time constraints regarding submission dates. However, this did allow me to ensure that the visual fidelity of the game was at a standard where the game was successfully playing at 70 plus frames per second, which does reduce the cause of motion sickness. Another thing I learned from this was the importance of using source control. When source control is implemented effectively, it allows participants of a project to review previous changes and narrow down areas where bugs or errors could have stemmed from. This would save a great deal of time and possibly escape the need to recreate or lose work entirely. Although source control doesn't impact the project at a level a user would be aware of, it does provide safety and a way to troubleshoot problems throughout the development process, which would have allowed me more time to build on the project's functionality. The lesson here was that it's better to have it and not need it, rather than need it and not have it. I am now going to go through the gameplay. First, I will adjust my position at the machine to suit my height. Being that this is a prototype, I kept the UI minimal to function more as a placeholder to briefly inform the player of any relevant information. When select is pressed, the game state enters Choose Game Mode. This changes the UI and the buttons to reflect this. Now it's time to select the desired gameplay mode. The UI and buttons change again due to being in the play game state. The current game mode displays at the top to remind the player. During a 1x multiplayer, each correct mole hit earns 5 points. A 2x multiplier earns the player 10 points. The 3x multiplier is where the challenge increases. Each correct hit now earns 15 points, but now the speed increases along with the reaction time required from the player. An incorrect hit will reset the multiplier along with the game speed and the music speed. You may notice the change in not only the music but also the mole's sounds. To mimic multiple sounds, I implemented a pitch change at random. As the game ends, the player's stats are shown along with the new buttons. This happens automatically as the game state enters End Game State. Just to show the restart functionality, I will quickly restart the game and then quit so I can change the game mode. I'm not sure I want to correct this at the end, as I feel although the moles aren't required, it's still fun to whack them. Now I will enter the odds game mode. This can catch you out when switching between odds and evens, which is something I observe when watching and listening to testers. Everything else between the two game modes is the same, but the simple change from even to odd or vice versa is enough to catch you out. Something else worth noting is, as this is supposed to be an educational game, I do not punish the player for not attempting to hit a mole. Having a target to meet rather than a set timer allows players to play at their own pace and slowly build on their confidence and ability. Now you've seen the game in action, let's focus on how the game actually works. For the purposes of this game build, I chose to code in a way that I was familiar and confident with, as opposed to using a specific framework. On reflection, with the affordance of having more time after the submission of this project, my aim is to implement the Liskov substitution from the solid principles. One area where this could be implemented would be to advance the moles in the game. I would do this by having the base form of mole, but then creating a golden mole, for instance, which still has all the inherited aspects of the original, with some extra added benefits for points value, etc., etc. In certain aspects of the code, I have implemented the observer pattern. One example of this being checking when the game state has changed. On game state change, the signal is fired out, which is received by a group of classes listening for this event, such as displaying the correct UI, which can be seen in the game manager scripts and score manager. And as can be seen here, it shows that if the game state is in the choose game state, then the score manager will listen and reset the scoring values to allow for a fresh gameplay. The same is seen in the UI manager, showing that when the player makes a selection within the game, it will automatically adapt the on-screen visual to reflect the current state and feedback to the user. For example, within the button manager scripts, this pattern is also used to show and display the correct buttons that the player needs to progress with their gameplay. Whilst on the topic of game state change, When using the observer pattern, I adhere to the common rules that say if I'm going to subscribe to an event, then I will also unsubscribe to the events using the onDestroy function to avoid null reference exceptions and errors. I also use static manager instances for scripts that dealt with the UI elements, another for dealing with the score in Game Manager. That dealt with all game-related functionality. This allowed me to communicate between the scripts without having to reference each script individually and have direct dependency to each other. One area for improvement would be the player height script. It has a dependency as the script is using a tag to detect the player. To fix this, I would implement an interface. For example, I height change that the player would implement. This would avoid any errors as the object wouldn't be checking for a specific object reference. This reduces dependency and adheres to the solid principles. The goal was to have moles spawn randomly between 6 different holes on the machine. In an IE numerator, there is a while loop that spawns the moles while certain conditions are valid. They would spawn up at random between 2 float values and despawn between another set of random float values. When the moles are spawned, they are assigned a random ID that is shown above the mole's head. Another while loop is used to check if the time passed is less than the time before pop-down value, and a check to see if the mole has been hit. If not, the mole will despawn. If the player has been hit, the mole ID is passed into the Game Manager script. For example, if the game mode is evens, the Game Manager will pass this value into the game mode evens function, where the ID will be checked to see if it's a correct hit. The syntax to check if a value is even or odd is quite simple. You pass in the value and check if it divides equally with 0 remainders. An odd number will divide with a remainder of 1. If the mole hasn't been hit and the time exceeds the pop-down value, the mole will turn off its ID and its collider and then trigger the despawn animation. At the end of this while loop, before re-entering, it checks if the endgame bool has been called and if the current amount of correct moles hit matches the amount of required correct hits. If not, the moles will continue to spawn. When the target has been reached, the game will end. Next, we will look at the Game Manager script in more depth. This class manages all the gameplay and is responsible for deciding what state of the game the player is in. Here I have used multiple enums and state machines which are utilising the observer pattern to call functionality depending on the game's current state. When the game's state changes, an event is fired, which other scripts listen for and then fire off their relevant functions. This removes dependencies between the scripts as the Game Manager has no idea what's listening, nor does it care. Protection is placed here by saying on-game state change ? .invoke. What this does is it checks if anyone is subscribed, and if they are, continue. If not, then don't send the signal. In the UI Manager script, I am able to display the correct UI with a simple line of code. In this example, we've got idle state menu.setActive, and then if state equals game state.idle game. Now, this UI for the idle state will only show if the game state is in idle. It will also automatically disable when it is not. This has been a very productive way to keep code readable and unspaghettified. The mole script could be more efficient as it is responsible for many different tasks. In a future update, this could be changed to adhere to both the single responsibility and open-closed of the solid principles. For instance, if I break this functionality down into multiple scripts on the mole, would have mole spawn, mole animation, mole ID, mole audio, mole collider, mole particle effects, mole hit, and so on. This would mean that these behaviors would be encapsulated within their own scripts, adhere to the single responsibility principle, and have the ability to be extended without breaking other elements of the logic. I would probably also refactor the framework to utilize both the observer pattern and composition pattern in place of using an inheritance hierarchy. This will allow me to further extend upon the mole's behavior and add additional moles with special bonuses without being forced to implement specific behaviors to regular moles. If I also utilize interfaces amongst this framework, as mentioned earlier in this video, the project would be adhering to 3 of the 5 solid principles, which would provide further future-proofing and allow for updates to provide more game modes, weapons, and other mole behaviors. And on to the conclusion. Overall, I feel that the process of creating this game from start to finish has given me many opportunities to enhance my prior knowledge and understanding surrounding virtual reality. The coding process and the affordabilities that come with using software such as Unity. There have been many areas where I have struggled but persevered to gain the necessary answers to allow the game to flow smoothly while still fitting in with the traditional aspects of arcade games. Also immersing the player in a VR experience that is built around the educational aspect, which when delivered in other formats can prove to be dull and unexciting. I now look forward to being able to work further on this project to implement more things from the feedback given from testers to enhance the gameplay even more and hopefully adding more game modes. One theme that appeared throughout the written feedback was that the actual ending of the game could do with further development, both visually and probably auditory, to provide more impactful feedback to inform the player of the current state of the game. I feel like the game itself links directly with findings from my previous research in the literature review, and has shown that VR and arcade games can be blended effectively to allow for enjoyable gameplay without the occurrence of motion sickness or boredom, and also being accessible to a wide range of demographic. 50% of testers felt that this game appealed to the age range between 5 to 12, whereas the other 50 felt that this game could be played by people of all ages. As I mentioned at the beginning of this video, one of my goals was to make learning fun. I feel that this has been done to a degree of success, as 75% of participants felt that this game felt both gaming and educational. I look forward to now working on similar projects such as this to allow my skills to progress even further. Thank you very much for watching.